Okay, so we're going to look at two of the formula that we use in coordinate geometry. So all of these formula are in your formula and tables book that you would have with you in an exam situation. So in a test or an exam or anything like that, you'll have your formula and tables book with you. So you don't need to know them off by heart, but I suppose you need to be familiar with them to the point of basically knowing them. Is kind of where I would say you would need to be at. So essentially knowing them, although you obviously can check them on the day, so there's no kind of fear of you writing it in incorrectly. But the first one we want to look at here is the midpoint. So kind of by the name of it, we kind of expect midpoint. It has the word mid. It's going to be the point that's the middle between maybe two given points. And that's kind of exactly what it is here. So if I'm given 2 points, P and Q, where P I might label as x1, y1, just to indicate here that it is the first point. So that's all that the little subscript indicates, is the 1 is just because it's the first point, and Q might be x2, y2 because it's the second point. That's all that those indicate, is just to differentiate the two. We know from coordinates that x comes first and then y, so that kind of down the hall up the stairs idea, and it's just to differentiate between the 2 points. If I apply that then to my formula, it's x1 plus x2 over 2, y1 plus y2 over 2. So it's basically nearly that idea of an average, nearly the average x value and the average y value, or the mean x value, the mean y value. And just a note there really of what I was saying there about x1, just the first coordinate, the x coordinate of the first point, y2, the y coordinate of the second point. Distance then, the second formula then that we want to look at. If I want to find the distance between 2 points, again labelled in the same way, then I'm using my formula square root of x2 minus x1 squared plus y2 minus y1 squared. And again, this formula is given to you in exactly this format. This is copied directly from your formula and tables book for you here, just so you can be familiar and see it in the same way. So let's see about applying those two formula here to some examples. We're just going to kind of quickly go through these sort of ideas here. So looking at finding the distance and midpoint of the line segment joining each of the following points. So let's look at them each in turn. Let's start maybe by labeling our points here. So if I start with point P, that's the point 1, 3, and Q then is the point 5, 7. So I might decide then that P is going to be x1, y1, and Q is going to be x2, y2. The actual order there, whether you decide to call it x1 or x2, actually makes no difference so long as you're consistent. So obviously by deciding P was my first point there, I stuck with x1 and y1. We couldn't have x1, y2 within the same coordinate there. That wouldn't really make sense with the way that we're setting this up here. So let's start by doing distance. The first thing I'm going to write down in all of these questions, nearly following, kind of mentally following that kind of FIFA idea that we had on the side here, is just going to be the formula. Okay, so I'm going to start by writing down my formula, x2 minus x1 squared plus y2 minus y1 squared. Okay, once I have my formula down correctly and I'm happy, my information there, I suppose, is the point that I have above. I'm going to fill those in then to the formula. So x2 is going to be 5 minus x1 minus 1 squared plus 7 minus 3 squared. And then it's just a matter of kind of doing those smaller sums. So 5 minus 1 is 4, 7 minus 3 is also 4. So we get square root of 16 plus 16, which is the square root of 32. And I could lastly maybe just check that on my calculator to see, does that simplify down further? And it simplifies to 4 root 2. So given my answer there in what we might call surd form. So we might see that in a question. They might say surd form, or they might talk about our form being a root b, or something of those lines, just to let us know that that answer is okay. We can see in the calculator there is a decimal version of that, but a lot of the time with those sort of answers, we take them as, yeah, that is actually a correct answer, that's a valid answer. I'm just going to leave it in that format. The next thing we want to find then is the midpoint. So the midpoint between the 2 points that we have here. So again, I'll start by writing down my formula, which is x1 plus x2 over 2, y1 plus y2 over 2. I can fill in the relevant values here. So again, scrolling back up, x1 is 1 and x2 is 5 all over 2. Then y1 is 3 and y2 is 7. All over 2. Okay, and I could maybe simplify that down if I can. So 6 over 2 10 over 2, and that's going to simplify down to just 3, 5. And expecting here that the solution to my midpoint would be a coordinate, whereas the solution for my distance was a unit, or was a distance, I suppose. So I might put in units there for that, or if it was given in the question, I'd obviously put in the valid unit of measurement there. Okay, let's apply the same thing then just to another example of the same idea. So again, I'm going to take my 2 points here. I'm going to start by labeling the two. We'll call C x1, y1. We'll call D x2, y2. I can immediately see there are some signs here, some negative signs that we're going to have to pay attention to, and that's absolutely fine. So let's have a little look at those. So we'll start with our distance again. We'll go with CD first of all. So that's going to be the square root of 5 minus 2 squared plus minus 7 minus 3. And you can see here I'm using an extra bracket here because I'm conscious of the signs that I have going on here. I have a minus 3. And I know I'm going to have to adjust that in the next step, but I'm allowing myself that extra line before I do so. So that's actually going to become minus 7 plus 3, because the minus 3 overall is going to work out as a plus 3. So that's going to give me minus 4 squared. So 9 plus 16, which is the square root of 25. And square root of 25 works out as a nice whole number, just 5 for me there. Or we could say 5 units, I suppose, because we're looking at distance here. Looking at midpoint then. So my midpoint, again, I'm going to start by writing down my formula. I know it can seem kind of monotonous to write down the formula every single time, but it is important. I suppose this is one of the ways, obviously, that you're going to get familiar with the formula. And also it's just to ensure that you're getting those kind of first few marks. So the marks for picking out the right formula and then for substituting into the correct formula. And you're always kind of picking up marks everywhere along there. So minus 3 minus 7 over 2. So that's 7 over 2 and minus 10 over 2, which I can just break down if I wanted to write in decimals, maybe is 3.5 and minus 5 there as my midpoint. So we've kind of worked out successfully slope and midpoint for the two sets of coordinates that were given there. So we can see just using our formula, subbing the points in, that kind of first step of labeling our points correctly is kind of the key step to start us off there. We'll just look at one more example then of a different type of question using the same formula. We're asked here to find the value of one of our coordinate points if we're given the distance to be 5 units in this case. So again, I'm going to start as normal. I'm going to label my 2 points, x1, y1 and x2, y2. I'm noting in the question that they're mentioning distance, so I'm thinking I have a formula for that. So let me write down that formula. In the log tables it uses PQ, so that's what I'll use here. x2 minus x1 squared plus y2 minus y1 squared. I'm not saying I know exactly where I'm going yet, but I'm just filling in the information that I can here. So again, following that kind of FIFA idea. So looking at I then standing for information. So the information I have in this case is I have my points. So I know x1, y1, I know what those are. So that's k1. And I know my minus 1, 5 is x2, y2. And I also know that the distance between the 2 points is 5 units. So I have a lot of information I can fill in for the next line. So 5 is equal to the square root of, and that's going to use my colors again, minus 1 minus k, so the minus there from the formula, plus y2, 5 minus 1 squared. Okay, now I can see here, I'm going to just do some of those individual sums, but I can also see that there is a square root that I'm going to have to get rid of as well. So we're kind of thinking ahead as to that. Minus 1 minus k I can't reduce down because those are unlike terms. I have a variable and I have a number. I can't put those together in any sort of way. What I could do is reduce down the 5 minus 1 to be 4 squared. So what I'm getting overall here is minus 1 minus k all squared plus 16. I'm at a bit of a loss here, so all I can do is try and get rid of my square root, and to do that I need to do the opposite, which would be to square both sides. So squaring power of 2 and a square root are inverse operations of each other, same as like multiply and divide. So to get rid of one, I need to do the other, and I need to make sure I do it to both sides. So 25 equals minus 1 minus k squared plus 16. Let's multiply out that bracket, making sure we don't forget our middle term of 2k there, plus k squared plus 16. Gathering everything together on this side, k squared plus 2k, and that's going to give me an overall answer of plus 8 here. Okay, so that's my 16 minus 1 minus 25. Oh, excuse me, gone wrong there somewhere. 16 minus 1 minus 25 is going to give me minus 10. Excuse me. So I want two numbers that are going to multiply to give me minus 10, but that are going to add to give me plus 2. Okay, so we're solving our quadratics here and kind of bringing ourselves back a little bit to those sort of questions here. Oh, and excuse me, actually that should be a positive 1. There we go. I knew there was something along here that wasn't going right for me. 16 plus 1 minus 25. There we go, my minus 8 that I wanted. It's all making a bit more sense now. So solving my quadratic, k plus 4, k minus 2 equals 0. So k equals minus 4 and k equals 2. Okay, got there in the end. That's all we can ask for. So making sure we obviously have all of our sums done correctly there. We can see, even for myself, making sure my signs are working out correctly also. So we've got k plus 4, k minus 2, so k equals minus 4, k equals 2. Those are my two possible answers for k, and in this case those are my two answers. It is what it is. What actually is probably happening here is I have one point here, and I might have a point either side of it where the distance between the two is still 5, but each point is maybe kind of to either side of that point that I have in the middle there. Okay, the main takeaway here really is this use of the formula. So making sure we're confident with those formula and making sure that we watch out then for obviously all those little mistakes that can come from the use of those formulas also. But yeah, overall midpoint distance, it's just using the formulas, labeling your points correctly, and then ensuring you substitute in the correct way.